one more theorem here, one more important idea, and that's the net change theorem. And this one says is that if we integrate the derivative, make a definite integral of the derivative of a function, then we will be getting the net change in the function. And how much did it change from A to B? What's the difference between f of B and f of A? So how much did it change between those two? The net change. Now, let's take an example where we can use this. So that's integrating the rate of change. Gives you the total change. Okay, now, how can we use that? If the velocity of a particle moving in a straight line is given by this, then find the displacement and the total distance traveled by the particle over this interval of time. Okay, so we're going to get displacement, and we're going to get total distance. Okay, now, displacement is this interval. Okay, and that would be the net change in the position. So that would give us the displacement. Let's go ahead and do that. I'm going to integral from 0 to 3. Our function 5t minus 7 dt. Okay, now this one over here, displacement would just be this integral. This is no problem. Let's see, we're going to have this 0 to 3. This will be 5 times 9 over 2 minus 21, which is 45 over 2 minus 21. And that is, let's see, it's 22 and a half minus 21, which is 1.5. Okay, 22 and a half minus 21, 1.5. Okay, total distance. Now we got to be careful with this one because we want to want the absolute value here, because some of these values would be negative. We don't want that to contribute negatively to our total total distance travel. Let's put it that way. This will give us the complete, like we set up here. This gives us the net change. In other words, what's the difference between in our case, we're working with V here, which is S prime. So that'll be S of B minus S of A. So that gives you the distance in the position function. So and that doesn't account for negatives, let's put it that way. So now to calculate this one, you're going to have to look at this function in two pieces and integrate each one separately. So this will give us our positive a positive value for all movement at all. So there won't be any negativeness in here at all. Everything will be positive, because remember, we can interpret this as this quantity underneath the curve and above the x-axis. So this function over here, 5t minus 7, you're integrating that, it's coming through like so, and you're getting some negativeness in here as well as some positive, and then what they end up, they average in and give you that total 1.5. Some of that's negative, some of that's positive, but the net result is a 1.5. Now it could have been negative depending on the interval. That answer could have ended up negative, but it didn't. Anyway, over here, this guarantees we're going to get all positive results, and we'll have the distances traveled during each amount of time. So you got two integrals here. You're going to go from 0 to 7 over 5, 7 minus 5t dt, and then you're going to add to that 7 over 5 to 3, 5t minus 7. This portion is positive here. So we got a little bit of work here. 7t minus 5t squared over 2 from 0 to 7/5, and a 5t squared over 2 minus 7t from 7 to 5 to 3. So we've got some arithmetic to do here. I think we can get it done. So you'll have a 7 times 7/5 minus 5 times 49 over 25 over 2. The rest of that's a 0. And then over here you'll have, this way it's going to work, 9 over 2 minus 21 minus 5 times 49 over 25 over 2, and minus, let's see that once. Okay, and then finally, I'm going to cut to the chase on this one. You're going to get 13 over 10 as your total.